Spilek to everyone. So today we will be continuing with the chapter continuity and differentiability. And in the last class we had discussed how can we find the derivative of a given function using the chain rule. Okay, so we will continue from that. We were doing this chapter continuity and differentiability. Okay, and from this chapter we had completed the topic of continuity, that is how can we check the continuity of a function at a point. And after that we had also discussed about how can we find the derivative of a function when using the chain rule. Okay, so now here in this topic differentiability, you will be asked to find the derivatives of different functions, different types of functions, and in every function, whenever you are differentiating a function, in that you have to find the derivative of y with respect to x. Okay, so in all functions you will always consider y as your dependent variable and x as your independent variable. So that is the standard thing you have to remember, right? Okay, so now today we are going to discuss about how can we find the derivative of implicit functions. First we will discuss this. So first we will understand what do we mean by implicit functions, and then we will find the derivative of such functions. Okay, now till now whatever functions you had considered, all were in types of y is equals to f of x. Okay, so we always consider our function y in terms of x, where we express y in terms of x. So you consider a function like this, y is equals to say x squared plus x plus 1. So this is a function y. So in such case you can find the derivative of y with respect to x very easily, right? So differentiating both sides you can obtain the derivative, right? Similarly, if I consider y is equals to sine squared x plus 10x, right? So this is again a function where we are expressing y in terms of x. Okay, so every function in which you can keep y at one side and all the other terms which are in terms of x and constant terms, you can keep it in right side. So this type of functions are called as explicit functions. First you should know the meaning of implicit functions before finding the derivative of such functions, right? So first you just understand what do we mean by explicit function. Okay, so explicit function means where you can express y in complete terms of x. Okay, so you can keep only y at left hand side, remaining all the terms on the right hand side which are in terms of x and the constant terms. So such functions are called as explicit function. Okay, now if I give you an example, say if I write xy plus y plus 1 is equals to 0, right? Now if I try to express this function in the form of explicit, then am I able to do it? First you need to check that. So now what I will do is I will keep the terms which with respect to y, okay, which are in terms of y on the left hand side, and then I'll take that on the right hand side. So I get here minus 1. So from these two now I can take out y common, right? So from these two I can take out y common. So here I'm left with x plus, here I have 1. So this is equals to negative 1. So now I can write y is equals to negative 1 upon x plus 1. So here in this case I had expressed y in complete terms of x. Okay, in complete terms of x means the expression which does not include y as its variable. So now here I had written y is equals to negative 1 upon x plus 1. So now this function becomes an explicit function because I am able to express y in complete terms of x. So this is an explicit function. Okay, so when you have such function, then easily you can differentiate it by differentiating both sides. So you will get here dy by dx. Derivative of y with respect to x is dy by dx. This is how we write. So dy by dx is equals to, and to find the derivative here you will apply quotient rule because the function is in terms of a fraction. So you will apply quotient rule and then you will find the derivative. Okay, now if I take a function, okay, for example if I write okay, square root of x plus y plus y square plus x squared is equals to 0. Okay, so if I consider this function, now I will check whether I'm able to express y in terms of x or not. Y in terms of x means y should be on the left hand side, only y should be on the left hand side, and everything should be on the right hand side, where this is a complete terms of x. Okay, so now I will try. First I can transpose that, so this term is whole square, so I cannot split that out. So this plus y squared is equals to negative x square, right? Now it's impossible for us to express y in terms of x, because square root of x plus y means we cannot split that out. We cannot separate this two, right? So therefore you cannot separate x and y. So because of which now we cannot express y in terms of x. Okay. So this type of function is called as implicit function. So implicit means every term will be a mixture of x and y, where you cannot separate x and y separately. You cannot do that. Okay, so this is an example of implicit function. So implicit function means where you cannot express y in terms of x, like in these two examples. Okay, so when you cannot express a function in terms y in terms of x, then such function is called as implicit function. Okay, so when your given function is explicit function, then it is very easy for us to obtain the derivative. By differentiating both sides, you can obtain the derivative. But in case of implicit function, how we are going to differentiate it? Okay, so that we are going to see, okay, here in this topic, finding the derivative of implicit function. So first you should know, when do we say that a function is implicit function? Okay, so after that we will see how can we differentiate an implicit function. So I'll give you one more example of implicit function. If I write sine of xy is okay, sine of xy plus x plus y square is equals to 0. So now in this case also, xy is the angle of sine, so you cannot separate them out. So therefore this becomes an implicit function. Okay, so these are all examples of implicit function. So implicit function means a function which is not explicit, and in explicit what we do, we can express y in terms of x. So that is called as the explicit function, and this is the difference between explicit and implicit function. Okay, now we will see how can we differentiate an implicit function. That's quite simple. Okay, so I'll take few examples and will explain you. I'll start from a simple example. If I write okay, square root of x plus y, okay, plus x plus y, okay, x square plus y square is equals to 0. Okay, now this is an example of an explicit function, right? Now what we are going to do is, now always remember that whenever we are differentiating any function, you always have to apply the chain rule whenever there is a need, whenever it's a composite of two or more functions. Okay, so I'll start like this. Differentiating both sides. Now I'm differentiating both sides, that is derivative of, now I have to differentiate this, that is square root of x square plus y square plus x square plus y square. This is equals to, derivative of 0 is 0. Derivative of a constant term is 0, so you don't have to write that. Now it is you can see this is a sum of three functions. Okay, so you can differentiate it term by term. So now we get derivative of square root of x square plus y square plus derivative of x square, okay, x square plus derivative of y square is equals to 0, right? So now this is every time whenever you are asked to find the derivative, or you are asked to find differentiate, if you are given a question like differentiate the given function, so always remember that you always have to differentiate the function with respect to x. Okay, so with the changes of x, we are finding out the rate of change of the function y. Okay, so every time you have to differentiate it with respect to x, whether it is specified or not in the question. Okay, so always you have to differentiate the function with respect to x. Okay, so now term by term we are differentiating it. Now you look here. this function. So chain rule, what we do, we take it as a whole function first. Okay, so now this is a square root function of which first we will differentiate it. Now we know that derivative of square root of x is 1 upon 2 root x. You remember that we had derived that. Okay, so derivative of square root of x is 1 upon 2 root x. So this is equals to 1 upon 2 root x. Now in this case, my x under root term is x square plus y square. Now here I'm applying the chain rule. So first you will differentiate this whole term into, now you have to differentiate this term. Is it okay? So now you have to differentiate the inside term, which is the sum of two terms. So you have to differentiate it term by term. So what is the derivative of x square? It is 2x plus. What is the derivative of y square? Okay, now we have to differentiate y square. So that is equals to, likewise you will apply the chain rule. So okay, first you will do like this. What is the derivative of x square? It is 2x. First you will differentiate this whole term 2x, right? Then what is the derivative of x? That is 1. Okay, 1. So first you are differentiating the whole term, that is derivative of x squared is 2x, okay, into, now you have to differentiate x, that is 1. So we don't write it usually. So we just write derivative of x squared is equals to 2x, right? Then when you are differentiating y square, so first you will differentiate this whole term, which will be equals to 2y, right? And then you have to differentiate now y with respect to x, so which will be equals to dy by dx. So you can see the difference between these two, right? The method is same. We are applying chain rule every time. So first you will differentiate this whole term, so that is derivative of x squared is 2x, and then actually we are differentiating x, but since its derivative is 1, so we omit writing into 1. Okay, so we just write 2x. Now whereas when you are differentiating y square, so first you will differentiate y square, which is equals to 2y, right? And then we have to differentiate y, and we are differentiating it with respect to x. So derivative of y with respect to x is dy by dx. Is it? So now you will write here derivative of x square is 2x and derivative of y square is 2y dy by dx, right? Okay, plus now this is done. Now you come to this term. Okay, now here we have to differentiate x square with respect to x. So that is 2x. First you will differentiate. So derivative of x is 1. So you don't have to write that. So derivative of x square is just 2x. Plus derivative of y square with respect to x is 2y. First you differentiate this into, then you get here dy by dx. Okay. So in implicit function we do is, instead of writing y in terms of x, we together x and y both, we start differentiating it term by term, right? So always remember that when you are differentiating a term which is in terms of y, then you will always get dy by dx, because at the end you have to differentiate y itself with respect to x, which is dy by dx. So every time whenever you are differentiating a function which is in terms of y, so then you will always get dy by into dy by dx at the end. So you have to remember that, right? So this is how we differentiate it. Now you will split out the terms and you will collect the like terms. Okay, so actually when you are asked to find out the derivative of any function, so you are asked to find out dy by dx. Actually this is the question. Whenever you are asked to find out derivative, so you are asked to find out dy by dx. Okay, so now I will collect the terms which are in terms of dy by dx together. I'll keep all the terms on the right hand side and then we'll try to find dy by dx. Okay, so you open the bracket. So now this will be 2x divided by 2 square root of x square plus y square. So 2 will get cancelled. Then this is to be multiplied here. So that is plus 2y by 2 square root of x square plus y square dy by dx plus, okay, 2x plus 2y dy by dx is equals to 0, right? Now from this 2 will get cancelled. Okay, now what I will do is I will take the like terms, okay, dy by dx together, and I'll take common. Okay, so okay, from this term and this term, these are like terms, so I will take dy by dx common from these two. Okay, so what do I get here? here I get y upon square root of x square plus y square plus, okay, from this I get 2y plus 2y, okay. So this is equals to, rest I will take it on the right hand side. So positive 2x, when I take it here, so you'll get negative 2x, right? And here this term, positive x plus square root of x square plus y square, when I take it over there, it will be negative x upon square root of x square plus y square, right? So at the end, I have to keep dy by dx at one side, all the other terms on the right hand side. So I'm going to do that. So I get dy by dx is equals to, so this will be negative 2x minus y square whole divided by, so this term you bring it here, 2y plus y upon square root of x square plus y square. Like this we will do. Is that clear? So you can now simplify the terms. Now this is what we want to find, okay? And now we got everything, but you need to simplify the terms now. So I can do it like this. So dy by dx is equals to, now from this two I will take out negative common. So now when you multiply it over here, so you get 2x square root of x square plus y square minus x whole divided by square root of x square plus y square whole divided by, so similarly you will write it here, 2y, when you get the square root of x square plus y whole divided by square root of x square plus y square, right? I'm just solving the fractions on the numerator and solving the fractions on the denominator, so I get this. Now this two I can cancel. Here you cannot cancel the two terms because we have these two terms, right? So first you need to simplify them, and then now since it is whole divided by square root of x square plus y square, it is whole divided by square root of x square plus y square. Now I can cancel out these two terms. Okay, since I take a negative common, this will be plus, okay? So now my dy by dx is equals to, on the numerator, this negative is there. On the numerator, I have 2x square root of x square plus y square plus x whole divided by 2y square root of x square plus y square plus y. Is it clear? Okay, now you cannot cancel out these two 2's. You cannot do that because here this term plus x is also there. So you cannot cancel 2 from here, okay? So now this is in the simplest form. So now you can keep it like this. So dy by dx is equals to negative of 2x square root of x square plus y square plus x upon 2y into square root of x square minus plus y square plus y. So this is how you will find the derivative, okay, of an implicit function. So there's nothing new. So instead of earlier when you were given the explicit function, that is quite simple because y is on the left hand side and all the other terms are on the right hand side. So directly when you differentiate both sides, you get dy by dx is equals to, so we get the required derivative, right? But in case of an implicit function, what you will do is you will start differentiating both sides, and in the left hand side, on the left hand side, there will be terms which are in respect with respect to x and y both. So you need to differentiate both, okay? And at the end, you will express dy by dx is in terms of this thing, okay? So this is the required answer. So in this way, you have to do. So always remember that at the end, you have to find out, or you have to express your solution as dy by dx is equals to, and you have to keep all the other terms on the right hand side. So this should be the format of the answer when you're differentiating a implicit function, okay? So I will take one more example. Now using the chain rule, product rule, quotient rule, everything is there, okay? Whenever you are differentiating it, any function, so if it is a product of two functions, then you need to apply product rule. If it is a quotient of two functions, then you need to apply quotient rule. If it is a composite of function, then you need to use chain rule. So these are the basic things, okay? But we are now seeing different types of function, and we are trying to obtain the derivative of these types of function. Okay, for example, now if I have sine of xy plus root y plus 3x is equals to 0. Okay, now if I give you this function, so this is an example of an implicit function. Okay, so instead of wasting your time on expressing y in terms of x, directly you just start differentiating. Okay, so you start differentiating both sides with respect to x. Now you always remember that whenever in the whole syllabus, okay, you always remember that whenever you are asked to find the derivative, you always have to find the derivative with respect to x. Okay, so now I'll start differentiating it. So this will be derivative of, term by term you can differentiate it now, sine of xy, okay, plus this is derivative of root y, plus this is derivative of 3x is equals to 0. So derivative of 0 is 0, right? So now first you will differentiate this. So first it is a function of sine. Okay, so as a whole you will differentiate. So that is, what is derivative of sine? It is cos. So this is cos. Okay, cos sine x. What is the derivative of sine x? It is cos x. So what is the derivative of sine of xy? So you will write here cos of xy. Okay, into, then now you have to differentiate the angle. Okay, where you can see that angle is the product of two functions x and y. So now we need to differentiate the angle which is product of two functions, right, x into y. So now we have to apply here product rule. So you can see in this function we are applying simultaneously chain rule and product rule together. So first you will find the derivative of x. Derivative of first function is 1 into second function as it is, plus first function as it is, derivative of second function is dy by dx. So derivative of y is dy by dx. So derivative of first function, derivative of x is 1 with respect to x, since we are finding out, so that's why it's 1. So derivative of x is 1 into y as it is plus x as it is into derivative of y is dy by dx. Now that's it. Okay, now you come to the second function plus. So now this is, what is the derivative of root x? It is 1 upon 2 root x. So first you will differentiate this 1 upon 2 root y, right? Now you need to differentiate this term y, which is dy by dx, plus what is now the differentiative derivative of 3x? So that is 3. 3 you will keep it as it is. You will differentiate x, that is 1. So this is 0, right? Now you expand the term and take the collect the like terms which are in terms of dy by dx. So now this is y. So I have y into cos of xy plus x into cos xy dy by dx plus 1 upon 2 root y dy by dx plus 3 is equals to 0, right? Now you take dy by dx common. So what do I am left with here? So this is x into cos xy plus, from here I'm left with 1 upon 2 root y. So this is equals to, now remaining you take it on the right hand side. So this is negative 3, and when I take it over here, so that will be negative y cos of xy. Okay, now you bring this on this side. So we have dy by dx is equals to, from these two you can take out negative common. So here I have 3 plus y cos of xy whole divided by, so now this is x into cos of xy plus 1 upon 2 root y. So this is the derivative of this implicit function. Okay, so in this way you will obtain the derivative of implicit function. So always remember that it's quite similar to find the derivative of explicit function, but in this case what is new is you need to differentiate y also. So always remember that y is the derivative of y with respect to x is dy by dx, right? Derivative of x with respect to x is 1. So derivative of y with respect to x is dy by dx. So you just have to add that. So it's like you differentiate root x, that is 1 upon 2 root x. Similarly you will do it 1 upon 2 root y. But then you need to differentiate y, which is dy by dx. if here we have x, then we just write 1 upon 2 root x, and then we are differentiating, actually we are differentiating x, that is 1, so therefore we don't write that. Into 1 we get when it is x, so therefore we don't write that, but derivative of y is dy by dx. Okay, so this is how we differentiate implicit function. Okay, so now here I'll suggest you to solve these two examples by yourself once again, by just pausing the video, and you go through these two examples again and try to solve it by yourself. Okay, see if you have any problem in that or not. Okay, next we will see the derivative of inverse trigonometric functions. Okay, now inverse trigonometric function. Now you know the derivative of the trigonometric functions. Like we have the formulas to find the derivative of sine x, derivative of cos x, derivative of tan x, derivative of sec x, derivative of cosec x, and derivative of cot x, right? So you have the formula to find out the derivative of the trigonometric functions, right? But now you had been introduced to the inverse trigonometric functions also. Okay, so till now we had not derived the formulas to find the derivative of inverse trigonometric function. Okay, so using the concept of implicit function, we will try to derive formulas to find out the derivative of inverse trigonometric functions also. Okay, number one, see, if you want to find out the derivative of sine inverse x, if you want to find out the, when your y is sine x, then you know the derivative, so dy by dx is cos x, is it? So derivative of sine x is cos x. So like that you have the formula for all the other 5 trigonometric ratios, but we don't have the formulas to find out the derivative for inverse trigonometric function. So I'm going to derive it. So now this sine inverse, when I bring it over here, I get sine y is equals to x. Okay, now I'll take this as an implicit function, and then I'll try to differentiate it. So now I get here, what is the derivative of sine with respect to x? So that will be cos y. As a whole, you will differentiate it. So the derivative of sine is cos, angle is y. So you will write cos y into, then you need to differentiate y, which is dy by dx is equals to, what is derivative of x with respect to x? That is 1. Okay, so differentiating both sides, you will get this. Derivative of sine y is cos y into dy by dx is equals to 1. Okay, so now I write dy by dx is equals to 1 upon cos y, is it? Okay, so now I will write this as this is equals to, okay, now you have this sin square y plus cos square y is equals to 1, right? So we have cos square y is equals to 1 minus sin square y. Okay, now taking square root on both sides, I have cos y is equals to square root of 1 minus sin square of y. So I'm going to write it here. So cos y is equals to 1 upon cos y is equals to square root of 1 minus sin square y. So we have this dy by dx is equals to this. So we have dy by dx is equals to 1 upon square root of 1 minus, now what is sin y? Sin y is equals to x. Okay, so I can replace this now. Sin y is equals to x whole square. Okay, so this is the derivative of sine inverse of x. Okay, so you can write this. Now earlier we had written a few formulas for finding out the derivative of some special functions like x raised to n, a derivative of 6 trigonometric functions, derivative of exponential and log function, right? So from there you will continue. Okay, so now we have this formula, so that is the derivative of sine inverse of x, derivative of y is sine inverse of x. So derivative of sine inverse of x is 1 upon square root of 1 minus x square. So this is the formula we have to find out the derivative of sine inverse of x. Okay, Now using the same method, right, expressing the given inverse trigonometric function into the implicit function like I did here to derive this. So with using the same concept, you can do for the rest of the 5 trigonometric functions. So you will get derivative of cos inverse of x is negative 1 upon square root of 1 minus. Now these are the formulas you will have to remember to find out the derivative of inverse trigonometric functions. Okay, derivative of tan inverse of x is 1 upon 1 plus x square. Derivative of cot inverse of x is negative 1 upon 1 plus x square. Derivative of sec inverse x is 1 upon x into square root of x square minus 1. And derivative of cosec inverse x is 1 upon x into square root of x square minus 1. So this is negative. Okay, so now these are the 6 inverse trigonometric derivative of the 6 inverse trigonometric functions, which is derivative of sine inverse x is 1 upon square root of. Now these are the formulas you have to remember, right? So the derivation is quite simple. I did it for the first one. So for this 5 also it's same. Okay, so derivative of sine inverse of x is 1 upon square root of 1 minus x square. Derivative of cos inverse x is, okay, now you can see that I had paired them in complementary functions, complementary trigonometric ratios. Sine and cos, they are complementary trigonometric ratios, right? Tan and cot are complementary, sec and cosec are complementary. So if you remember for sine, then for cos it will be negative of sine inverse of x, derivative of sine inverse of x. If you remember the derivative for tan inverse of x, then for the derivative of cot inverse of x, it is, you will take the negative of derivative of tan inverse of x, like that. Similarly, sec inverse of x, it is this derivative. For cosec inverse of x, you will take its negative. Okay, so these are the derivatives of the 6 inverse trigonometric functions. So this is how these are the formulas we are going to apply to find the derivative of these 6 inverse trigonometric functions, right? Okay, now we will solve one example, one small example. Okay, differentiate y is equals to sine inverse of 2x upon okay, now if I give you this, okay, differentiate y is equals to sine inverse of 2x upon 1 plus x square. You are given this. Okay, now since the given function is in terms of inverse trigonometric function, you may think that you have to apply this formula out of any one of these formula, right? But what happened is, now my function is in terms of sine inverse of x, so this will be the derivative of this function, where my angle here is 2x upon 1 plus x square, right? So some of you may start doing like this: dy by dx is equals to, what is derivative of sine inverse of x? It is 1 upon this, so that will be 1 upon square root of 1 minus x square. So here this angle, right here my angle is this, so that will be, you will write 2x upon 1 plus x square whole square, right? But you have to apply chain rule also. First you will differentiate this whole, okay, into, now you need to differentiate the angle, right, which is in the terms of quotient, so you have to apply quotient rule. So that will be very lengthy, right? So instead of directly applying the formula for the derivative of sine inverse of x, what I'm going to do is, I will think of applying certain substitutions so that easily I can obtain the derivative. Okay, for example, I will do, for this example, I will show you. Okay, now for that you should know all the trigonometric formulas you have. Okay, so now here I will write, if I put, let x is equals to tan theta, right? Okay, now since here you can see that it is sine inverse, so now what I'm going to do is, I will apply certain substitutions so that I will be able to express this in terms of sine. If it is in terms of sine inverse, then you will try to express this in terms of sine. If this is in terms of cos inverse, then you will try to express the term inside the bracket in terms of cos. You have to express this as the inverse of this. So if it is sine inverse, you will try to express this in terms of sine. If it is in terms of cos inverse, then you will try to express this in terms of cos inverse. If it is if it is tan inverse, then you will try to express this in terms of tan. Okay, so here I will take x is equals to tan theta. Now to make this substitution, all the formulas should come up in your minds quickly. Okay, so I can see that if I put tan theta over here, so I get 2 tan theta upon 1 plus tan square theta, which is the formula of sine 2 theta, if you remember, double angle formula. So I directly get that. So therefore I can now write y is equals to sine inverse of 2 into tan theta upon x is tan theta now by my substitution, 1 plus tan square theta. Okay, so this is equals to sine inverse of, this is sine 2 theta. We have this formula, sine 2 theta is equals to 2 tan theta upon 1 plus tan square theta. We have that. Okay, so in the class 11 you must have derived this. Okay, so now I can cancel sine inverse and sine. So now I'm left with these two will get cancelled. So now I'm left with y is equals to 2 theta. Now what is my theta? Theta is tan inverse of x. Okay, so now I have here y is equals to 2. So instead of theta, now I can write tan inverse of x. Okay, so till now I'm just simplifying my function. What is my question? I'm asked to differentiate. Now after simplifying the function, now I need to do the main thing, that is to differentiate it, right? Till now I was just simplifying the function. I'm not differentiating that function. Okay, now here I can directly obtain the derivative. So dy by dx is equals to 2 into, now what is the derivative of tan inverse of x? It is 1. Directly now I express this tan inverse of x, so that is equals to 1 upon 1 plus x square, right? So I have this now, dy by dx is equals to 2 upon 1 plus x square. So this is the derivative of this function, right? So now you can see, if you directly apply this formula without doing the substitution, then how lengthy it would be. Okay, so that will consume a lot of your time, and so therefore to avoid all this, you will just make this simple substitution. Now to make the substitution, the trick is you will try to substitute in such a way that you would be able to express this inside term, right, in terms of the inverse of the outside term. Okay, if it is in sine inverse, you try to express this in terms of sine. If it is cosec inverse, then you try to express this in terms of cosec. And how you would be able to do it after doing all these substitutions. Okay, so for that you should know all the formulas you have in class 11 trigonometric function. We had certain formulas, so using all this you would be able to solve it like this. Okay, so now first you need to remember these 6 formula to find the derivative of inverse trigonometric functions, and I shown you one example. Okay, so today you will do exercise 5.3, right, which is on the finding the derivative of implicit function and inverse trigonometric function. So today you will complete this exercise 5.3. Okay, so implicit function is quite simple, just a generalization of the explicit function. Okay, so you will find the derivative, and always remember that if you have to apply chain rule, you have to do that always. Now chain rule, product rule, quotient rule, these are basic things. You always have to use it whenever your function is expressed in any kind of that. So wherever there is a need, you have to apply chain rule, quotient rule, and product rule. These are basic. Okay, and on that you have to apply the formulas or the trigonometric identities, where especially in this type of question, for finding the derivative of inverse trigonometric function, you need to apply those trigonometric formulas also. Okay, so today we had seen finding the derivative of implicit function and inverse trigonometric function, right? Now in this chapter, under the topic differentiability, you will be differentiating different types of functions. Okay, so in the last exercise, in the last class, you were taught how to find a derivative using chain rule, how to find a derivative when your given function is in composite function. Okay, so today we had seen how we can differentiate implicit function and inverse trigonometric function. We had taken these two types of function, inverse trigonometric function and implicit function, and I had given you examples how can we differentiate such functions. Okay, so with this today I will conclude here, and as assignment you will do exercise 5.3. Okay, so you can see that whether you are able to do it or not, and if you are having any problem in solving this exercise, you can directly contact me through, what should I say, messenger. Okay, so you can message me, so I'll try to clarify your doubts as much as possible. Okay, so yeah, with this I will stop here. Thank you.